Alright, we are talking about section 5.1. This section is about real numbers, and we're going to talk about the number line. So a lot of these are going to be definitions, so we're going to start by giving you a couple of minutes to write these down. You're going to have to pause these to go ahead and write them, because I'm going to kind of move through them. But natural numbers are positive counting numbers. So I want you to see that these are located on the right side of a number line, to the right of 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you keep going. We're talking about whole numbers that are positive. So for example, your age. I know that when we were young, we used to say that we were 12 and a half, but that's really not how we calculate our age. We would just say a number. So ages would be with natural numbers. The next part are whole numbers. Whole numbers are exactly what we just talked about, those natural numbers that are positive counting numbers, and then whole numbers just include 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are whole numbers. Natural numbers does not include 0. Whole numbers includes 0. Integers is the next one. So what I'm underlining here are actually the vocabulary term. An integer is a positive or negative, they're all included, whole number and 0. So you see the ... here, and the ... after means we count all of the whole negative numbers and all of the whole positive numbers, and we also include 0. So for this one we have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So all of those are integers. Okay, so I've drawn a number line here. The black line across the middle is the number line. Underneath it, the red numbers show you what number you're counting by. So on the far left side, we start at -6, we count down -5, -4, -3 to 0. And then on the right side of 0, we have our whole number, positive numbers, which are 1, 2, 3, 4, 5, 6. So I do want to point out to you that 0 is neither positive or negative. It's neutral, okay? Doesn't fall in either one of those categories. Everything to the right of 0 is positive. Everything to the left of 0 is negative. I hope that some of this is just review for you, but I wanted to point this out to you. We will talk about opposites in your homework in My Open Math. And so when they ask you, if they give you, let's say, a +4, and they want to know what the opposite of +4 is, the opposite is the opposite sign. Same exact number, so the opposite of +4 is -4. So I just wanted to point this out to you in a diagram. Alright, the last couple vocabulary terms we have are rational numbers. These are all decimals that are terminating or repeating, fractions or mixed numbers, and any of them can be positive or negative. So I gave you a few examples here because sometimes these are confusing. So -1/4 is the first example. That is a rational number. The second one is 11/7. It's an improper fraction. Remember, we said mixed numbers are okay, so if I change the improper fraction to a mixed number, that's totally the same thing. Decimals, this is 1.5, so that's a rational number. -3 and 2/5, that mixed number is negative, and it's a rational number. And then here's your terminating decimal, and here's your repeating decimal. That means that 1.5 is exactly all that came out of the calculator when you typed it in. And then when you got this one, when it came out of the calculator, it was 1.18181818, because you're seeing that 1/8 with that bar over it means that the 1 and 8 are what's repeating. So all of these are rational numbers. The next set we want to talk about are what we call irrational numbers. And irrational numbers are not rational numbers. So what does that mean to us? It means that anything that doesn't follow this rule right here. Okay, so a square root of 18 comes out to be a decimal number that has no end. So it is not a terminating, and it is not a repeating. It doesn't have this perfect 1818 or 33333 repeating. It is a very long mixture of numbers as a decimal. This would be one that you would have to round. A lot of times we don't even find answers like this. We just simplify inside the radical, and you'll do that in pre-college algebra too. Same thing with 15, same thing with 23. If you type those into your calculator, you would not get a pretty number. And why is pi here? Some of us have a hard time with this one because we know that pi is 3.14. That's actually true, but sort of false as well. Pi is a never-ending decimal number. We round it and we use it as 3.14 in conversation, but your calculator is actually programmed every time that you'll push the pi button when you're in pre-college algebra 2 or higher levels of math. It will be that full, well, as much as it could program a full number. It literally is never ending. So pi falls under irrational because it is not a terminating and it is not a repeating decimal. It is never ending. So real numbers is the very last piece that we're talking about. And real numbers are every single vocabulary term that you have been taught in this lesson. So natural numbers, which are your counting positive numbers, 1, 2, 3, 4, 5. Whole numbers, 0, 1, 2, 3, 4, 5. Integers, -2, -1, 0, 1, 2. Those rational, irrational, the ones that we just talked about on this page, every bit of these numbers that we just talked about are called real numbers. There is a separate category called non-real, or actually imaginary numbers, and we will talk about imaginary numbers a little bit in the second class. But for right now, for this course, we're focusing on what real numbers are. And so that's why we've gone through these examples and through all of these definitions. You will need to know an example of every one of these for your test. Okay? All right. So we're going to go through these examples right here. So if I gave you number 5 or -5, I want to know, is -5 an integer, a rational, a real, an irrational, a natural number, a whole number? I just want to know what it is. So we know it's got a negative, we know it's a whole number, so immediately my first thought is it's an integer. Okay? It's also a rational number, and it's also a real number. So you're going to have to be able to not only know the definitions, but to apply them. I'm not going to ask you to write the definition of an integer, but you're going to have to, by definition, know that these numbers fall into those categories. So 2/3 is going to be rational, and it's also a real number. The square root of 14 is not a pretty number, right? So that makes it irrational. And it makes it real. Why is it real? Because everything we've talked about for this chapter is going to be real. So the square root of 9 is actually a pretty number. It's 3. And now we're talking about 3. 3 is a natural number, because you could be 3 years old, right? It's a whole number, because it's 0, 1, 2, 3, remember, whole numbers. An integer, because it's a positive or negative whole number, or 0, so it's an integer. It's rational, and it's also real. So I want you to know that the earlier ones we talked about, they're inclusive. So they actually fall into all of the categories. The only exception is it's either rational or irrational. It can't be both, okay? If it's irrational, it's only going to be irrational and real. If it is rational, it could be everything else that we talked about, okay? All right, let's move on. All right, so the next part we're going to talk about is we're going to compare numbers. And sometimes this is hard because we haven't really talked about negative numbers very often. I like to think of numbers always, especially when we're talking about negatives, we need to talk about them as money. So if I owe somebody $8, right, the negative means I'm in the hole or I owe something. And then the positive 5, which one's bigger? Which one's a greater amount of money? Which one would you like to have if we're talking about dollars? I hope that you would say you would like to have the 5. Because having $5 in your hand and owing someone $8, $5 is clearly the better option. If that is not making sense for you, I want you to think of a number line. Whichever number, when you write it on a number line, is the farthest number to the right is the biggest number. Okay, so let's look at this. If I have -8 and I have -6, which one's bigger? The one on the right is bigger. Okay, same thing for this. If this is negative or positive 27 and this is positive 300, the one on the right is always bigger. Okay, it may be one bigger, it may be just a tiny little bit bigger, but everything on the right on a number line is always bigger. So we're going to have the mouth eat the bigger number. So we're going to say that -8 is less than 5 for our final answer. All right, let's try another one of those. I have -10 and -6. Naturally, we see 10 and we say 10 is bigger than 6. But if we did this right, we would say here's 0, here's -1, -2, all the way down here is -6. I keep counting and then I get to -10. Whichever one's on the right when I'm comparing is the bigger number. And I want the mouth of this symbol to eat the bigger number. So -10 is less than -6. Okay? All right, so just briefly I want to talk about some opposites. The opposite of 5 is -5. If I gave you -6, the opposite of -6 is +6. And so for your homework, it's really just this simple. They want to know that you understand what the opposite is. And so a -18 given to you, an opposite is +18. +26 gives you an opposite of -26. So numbers stay the same, the sign just changes. Okay. All right, what about this one? They try to confuse you. They want to know which one is less. Well, it's a number line, clearly. It's a number line. They did it on purpose because they wanted to make sure that you understood how a number line works. They asked for which one's less. And we know that if it's on the right, it's always the bigger one, so that means the one on the left is less. So my final answer is going to be A. Okay, last one of these. Which one is less? Which one is less? They're not asking for a symbol on this one, they're asking for which is less. And so less would be on the left, and so -3 is going to be our answer. So make sure that you understand what they are asking you for, okay? We just talked about what the opposites were, and I want to give you a vocabulary term that they are asking for. Opposites are also the same thing as an additive inverse. Just means the opposite sign, okay? So if it's a decimal, it would just be this decimal, just a negative, right? Same thing. Last thing that I need to make sure that you understand is absolute value. So these two bars right here, straight up and down on the outside, and there's a number inside, those bars are called the absolute value bar. The rule for this is no matter what's inside, whatever comes out is positive. Well, 0 is kind of an exception because 0 is not positive or negative, so whatever comes out of the absolute value bars is just what you have for this one. But if I took the absolute value of 5, well, if I took 5 out, I had to make sure it's positive, and 5 is my answer. So let's look at this one. -5 is inside the absolute value bars. When -5 comes out, the absolute value bars takes that positive and makes it become negative, or sorry, takes the negative and makes it become positive. The rule is that anything that comes out of absolute value bars, with the exception of 0, will always be positive. So let's look at this one. There's a negative on the outside of the absolute value bars. And remember that this is understood, anything negative is understood 1, so it's like a multiplication problem. So when -5 comes out, it becomes +5, but I have to bring this guy over to multiply it times it, and I end up with a final answer of -5. So if there's a negative on the outside, it gets applied after it comes out. So -5 came out to be +5, but here's that negative that gets applied, and then that's how it became a -5. Okay? What if they give you a problem where there's something to do? Well, this is what I'm talking about. The absolute value of 8 minus 2. So I subtract, and I get 6. I take the absolute value of 6, and I have a final answer of 6. What if I have negative absolute value of 8 minus 2? I do the math, and I get 6. When 6 comes out, it stays 6, but this negative gets applied, and so the -6 is my final answer. So I want you to see if there's a negative on the outside, it does change the answer, your final answer. All right, that's all I have for this section. Make sure you do your TOYOs.